All right, everyone, welcome back to the factor zeros and solutions polynomial equations tutorial from the Algebra 2 Semester A class. We're going to go ahead and pick up where we left off from part 1 on slide 20. So now that we learned how factors are related to zeros and solutions, keep in mind we get our factors to find our zeros, which are technically also solutions, or in other words, our x-intercepts. Now, for every factor we get, depending on what the power is raised to, we're going to be able to tell whether when it intercepts, whether it will bounce or go through. What do I mean by that? So for this one right here, we have two intercepts, right? One of the intercepts is at 0 and the other one is at 4. So the idea is that here is considered a solution. So is this one. And the reason for I say when I mean by bounce, it will touch and then go back up. Or in this case, touch and then go back down. Now, this one, the function goes through the x-axis. What makes a big difference? So when it bounces, it is raised to an even power. Again, an even power. And then when it'll go through, it is raised to an odd power. So this polynomial is g of x equal to x squared, parentheses x minus 4 raised to the third power. So we know that x squared, right, will give us the intercept of 0, 0. Because it is raised to the 2 power, it's going to touch and go bounce away. X minus 4 to the third power provides us our intercept for the through the 4, but because it is raised to an odd power, it is going to go through. So that is the idea of the multiplicity of each factor. So again, even will bounce. So this is how they describe it. However the graph does pass through, or it returns in the direction it came from. And then if the factor has an odd multiplicity, the graph will pass through the point, but with a little curve before and after it meets the point. So again, make sure you take a note of that. You can go ahead and list it as multiplicity. Again, if it is even, right? So let me go ahead and kind of highlight what you should take as a note of. So if it has an even multiplicity, the graph doesn't pass through this point. It returns in the direction it came from, or you can put in parentheses, it bounces away. When the multiplicity is odd, or an odd multiplicity, it will pass through the point with a little curve before and after the point. So you can see it kind of curved off to the right, and then down, if you read it towards the left, it's going to curve off to the left side. Moving on to slide 21, which we have a question here. So it says, which statement about the graph of this cubic function is true? So it looks like the statements are talking about the zeros. So let's go ahead and analyze those zeros. You're going to first identify where is it touching on the x-axis. So you're going to go ahead and give me those two numbers. And with those two numbers, we know it touches here at -1. So we have -1, and we have this at 3. Now, the zeros are located at -1 and 3. We can now the question is which I think they're talking about the multiplicity as well. So we look at this one, the 0 located at x equals -1 and x is equal to 3, each have a multiplicity of 2. Is that true though? So we follow the graph. Right here it touches -1 and then it bounces. Here it goes through 3. So aren't those two different options down? The question is which one is going to bounce? Is it even or odd? And then this one goes through. So is the multiplicity even or odd? Make sure you go back to slide 20, which we discussed there. The 0 located at x equals 3 has a multiplicity of 2. The 0 located at x equals -1 has a multiplicity of 2. None of the zeros of the function have a multiplicity greater than 1. So go ahead and select the best option that is true about this cubic function. So technically we're not looking for both answers. I mean, we're just looking for that one specific statement that it is true towards this cubic function. Let's go ahead and take a look at slide 22. So there are instances with the polynomial function can't be written with a linear factor or of a real numbers, meaning that there are complex zeros. Complex zeros can't be shown on the x-axis. As we see the graph passing through only the real zeros on the x-axis. So here we have that it touches at -2 and 2, but we do have a complex number. So you can kind of see that it gives us like this little W shape. Normally when we see a W shape, the degree of the polynomial could be possibly 4. And also they give us a function. It is h of x equals parentheses x plus 2, parentheses x minus 2, and x squared plus 1. So if I even want to consider the degree, I have to count out the each exponent here. So this has an invisible 1, this has an invisible 1, has an exponent of 2. If I add them all up together, I get 4. That degree power of here is 4. Another way to prove that it's a degree power of 4 is to actually multiply all those 3 parentheses, and you'll see that you're going to get x to the 4th power. Now, in this case here, our complex numbers will not show on the x-axis. So you got to be very careful with that. We're not going to be able to determine that. The only way we are going to determine it is if we are given the function and we're given the degree power. Keep in mind, complex numbers, we not only we have the complex number itself and its conjugate. So, and technically we're provided not with just one complex number, but with 2. So we got to make sure we look out for that. Normally in cases, complex numbers come for 2 instead. So let's go ahead and take a look at this on slide 23. And when it loads, okay, so let's go ahead and take a look at the lesson activity together. As always, we're going to go ahead and work on it. I'll help you set it up. Don't forget to pause the video, take notes, or pause the video, work on it, and test yourself before you actually look over it or we do the work together. So let's take a look at this one. It says the table shows certain values of a 4-degree polynomial function. So we're already told it's a 4-degree polynomial function with no repeated factors. The function must have a 0 between the x values of blank. So we look at our options. So if we take a look at first, -12 and 10. So if we take a look from -12 to -10, let me highlight it. Look at our y values. From 280 to 81, are we going to go through 0? If you check the next one, -10 to -6, let me reset that and go right here. From -10 to -6, from 81 to -14, do I go through 0? Yes or no? So again, the function must have a 0 between the x values of blank and blank. And then you're going to continue going on. From -4 to 2, does that cross 0? Again, it says it must have a 0, so it should touch 0 somewhere there. Between the values of 2 and 8. So if we go right here, from 2 to 8, the graph of the function should be drawn one on, above, or below the x-axis. So another way to consider this is to graph it on your own. So it's going to be a rough estimate because you're going to go down to 280 and 81. It's not going to, if you roughly sketch it, right? It doesn't have to be exactly. We can say that this is -12 since this is the farthest, and this is 12, and it goes all the way down to 400. So I'll list it down below here, 400. 81 would be, oops, this would be -10, -6, -4, -2, 2, 4, 6, 8, 10. Okay, so then 81 should be like somewhere farther up. Again, this is not perfect. It's just an estimate. And you know what? I did this in the wrong direction, didn't I? Oops. Okay. Let me redraw this again because this is coming from the positives. So negative 12, we're going to say 280 is all the way from up here. Let me move me over here. All right. And then negative 10 goes down to 81. So let's just say it gets really close. And then negative 6, it's down to negative 14. Negative 4 is down to 0. 2 is at 0. And then we have 4 at negative 24. So let's just say here, 8 to 0, 10 to 126. So if I roughly draw this out, where am I at negative? Oh, 2, 0. So negative 4, 0. So it goes like this, straight line. Maybe I should change the color of this. So let me go ahead and change the color. So we have our graph that looks like this. Then it goes straight. And then it's 4. Oh, it goes all the way this way. And then it's 4, negative 24. And we kind of go up. Something like that. Okay. So again, this is a rough estimate. It's not exactly perfect, but we get an idea of what's going on for our function here. So it says between the x values of 2 and 8, the graph of the function should be drawn. So from 2 to 8, right? It's going from 0, negative 24 to 0 again. Do you see how it's talking about this specific area? Now, is that area above or below the x-axis? The function must be positive for all x values between. So we want to know when is it only positive. So again, if you look at the table, so like the first interval is from negative 10 to negative 6. Look at your y values to make sure it's between positive numbers. Here we go from 81 all the way to negative 14. Because we did that drop and we crossed through 0, this one does not work. Then we keep on checking. Again, it should only be for positives. Negative 4 to 2, we're at zeros. And then 1 to 3 and so on. You'll go ahead and take a look at that. Now let's go ahead and move into part B, question 1. Factor the polynomial p of x equals x cubed minus 2x squared minus 4x squared plus 8x. So I'm going to go ahead and get you started with it. Because we have 4 terms, you're going to go ahead and group them. So the best way to group them, you'll have the first 2 terms. So that is x cubed minus 2x squared, parentheses plus, and here, negative 4x squared plus 8x. So again, you want to take a look at the GCF for the first parentheses, and then the second, take the GCF for the second one. And then go ahead and write your factors out. It should be a list of parentheses there. Another thing we could have done before that is to also factor out an x. So if you saw that before, go ahead and factor out an x and then go ahead and continue. Because you still have those 4 terms, you're still going to go ahead and use the grouping method as well. So moving on to question number 2 here. It says use the drawing tools to the graph to graph the distinct zeros of the polynomial function. So once you're done factoring it all completely, remember that quick little trick right here where you look at each factor, take the opposite of that number, and you'll be listing your zeros there. Again, you're just going to go ahead and select points, and I'm selecting randomly. These aren't the answers here, but you should look something like that. And once you're done, you'll go ahead and hit submit. Don't forget, again, to do yourself an evaluation. And we're going to go ahead and move on to slide 24. So the application portion of this. So it says, let's look how to interpret the zeros of a polynomial in a real world context. Clarissa is making a gift box out of a 4-inch by 6-inch piece of poster board. She will cut out the square with a width of X inches from each corner of the poster board and then fold up the edges to make the box. Function f models the volume of the box in terms of X. So down below we have our polynomial 4x parentheses x minus 3, x minus 2, and we double check. They found our zeros there. So it's already graphed for us. Because we already have it graphed, we go ahead and plot those zeros. Then it looks like, again, this function represents the volume of the box. If the volume of the box is 0, technically I have no box, right? Because volume represents how much space I can hold inside. If I can't hold in anything that has a volume of 0, it doesn't exist. So then they're going to go ahead and test out between x and x is equal to 0 and 2, the function is positive. So here, another way to go ahead and plot this point, again, you can go ahead and graph it, or you can do a sign chart. And how I'll work the sign chart over here. So if we know our zeros, I'm going to draw like a number line. And we have our zeros. So that 4x gave me a 0 for one of my zeros or x-intercepts. X minus 3 gave me a 1, 2, 3. And that x minus 2 gave me a 2. So 1, 2. Okay. So now these are your main points, right? We know this is going to touch the x-axis. So you're going to look for numbers that are not listed on there. So like for behind 0, this is going to be -1. Between 0 and 2, it's 1. And between 2 and 3 is going to be 2.5 or 2.5. And I'm going to plug in these values into our equation here. So, but we break it up. So I'm going to put in 4x right here. Then it's going to be x minus 3. Now, when I plug in these values, I don't care for the actual value. I care for if it's positive or negative. Because again, remember, they multiply. So let me test out these points here. So we're going to test out, this is going to be -1, this is 1, and this is 2.5. And as well, you'll see how I go ahead and go about this. So for -1 times +4 is still going to be a -4 or just a negative. -1 minus 3 will still be a negative for -4. -1 and -2 will be -3. Now, again, yes, we can know about those values, but what happens when I multiply two negatives? I get a positive, and then when I multiply a negative, I get a final negative. So be anywhere from this side, the left side of the 0, it's going to be in the negative side. And you can tell. So I'm talking about this section right here. It's in the negative side. We do repeat the same thing for 1. 4 times 1 is still a +4. 1 minus 3 is negative. 1 minus 2 is also negative. So positive times a negative times a negative. Well, the first two give me a negative. Negative times a negative is a positive. So between 0 and 2 should be up above. That's this little area right there. It's above the x-axis. Then we do 2.5. 4 times 2.5 is still positive. 2.5 minus 3 is negative. 2.5 minus 2 is positive. Positive times a negative times a positive will give you a negative. So that is going below your x-axis. So it's talking about that area there. So if you really want to determine the numbers, you can go ahead and plug the actual values and get the numbers and plot them yourself. But again, you're trying to get a rough estimate of where those numbers are at. And so again, this is about the volume. Now, I wouldn't want to look anything below this area because this is a result of my volume. There's no such thing as negative volume, kind of like I've said it before. I can't go into Home Depot and say, oh, I need you to cut me -3 inches of this per piece. That doesn't make sense, right? So we can't consider the negative. We can only consider the positive area. Now, question is, are we looking at a particular part, or do we ignore another part? So again, that area is negative. They just want to reiterate that the positive versus negative. Again, you can use a table, a sign table, to go ahead and help you figure that out. So it says, notice that the function is positive for the x values greater than 4. Are these x values reasonable? So the question is, when is it? What could be the size of, because we have x to be, hold on. We'll cut a square with the width of x inches. So remember, the x-axis represents the width of the poster board, and then I have my volume. So does it make sense for my width of the board to be 1 inch and I have a volume of 8? That works, right? But once I get up to 2, I have an error here because it's in the negative. So then anything greater than 3 would give me a greater volume. So those are the contexts that we're going to go ahead and consider. And so following slide 26. Okay. So it says, let's look at a different situation. A company uses the function P to model the weekly profit, P of X, for selling X units. For what value of X will the company make a profit? So if we think about it, let me just draw just a rough sketch of the graph. They gave us a function here. And oops, I don't want it in yellow. I don't want to hurt our eyes here. It says X for selling the amount of units. So if anything, it's kind of try to relate it to like an actual storyline. Think of X as t-shirts that you're selling, right? And the x-axis is going to represent those shirts. I know it says units here, but let's just put more into the story of it. Let's say these are the shirts. Now, if the y-axis is about your money, right? You want your graph to go up as high as possible. That's how much money you're making. Down here is when you start making negative money. That's in debt. We don't want to be in debt at all. So let's go ahead and take a look at the function. If I were to graph the zeros, x minus 50 gives me, let's just say this is the 50 mark. And x minus 120 gives me like 120. So let's just put this right here. So these are my zeros. Now the reason why I didn't graph x squared plus 60, because that actually tells me I have a complex number. And if you remember, that is if you have two terms with x squared, or even if I try to solve it, right? So if you don't see it, you can take the factor, set it equal to 0. So x squared plus 60 is equal to 0. You subtract the 60 on both sides, and you're going to get x squared equals negative 60. Oops, I didn't even put negative 60 there. Kind of crammed it all in there. Sorry. And you take the square root. X is equal to the square root of negative 60. And now I can simplify, but again, remember our complex numbers don't get graphed. Now, if I do a sign chart to figure out, like say I test out 100. 100 squared plus 60 is going to be a positive number. This is a negative already. 100 minus 50 is positive. 100 minus negative is minus 120, it will be negative. So negative times a positive times a positive times a negative is still positive. So between 50 and 120, it's somewhere out here. If I did 200, right? Again, I'm doing a very rough sketch of the sign table. I'm going to go ahead and test out my value for 200 here. So let me actually get rid of this, and let me do this in blue so we know the different sign changes. I know 200 is not, let's just say 200 is like out here. Again, the scale is really bad, but again, we're just doing sign, just trying to figure out between 120 to 200, is it in the negative or in the positive? So right here I have negative. 200 squared plus 60 is still going to be positive. 200 minus 50 will still be positive. 200 minus 120 will be positive. Now, all these three positives still give me a positive, but this negative will actually make it go down below. And if I try anything less than 50, let's just say 20. Or again, let me do a different color because I'm doing the sign, I'm doing that sign change. So right here we have 20. This is negative. 20 squared plus 60 is also positive. 20 minus 50 is negative. 20 minus 120 is negative. So negative and positive is a negative, times a negative is a positive. Negative times a negative. Oh, wait, hold on. That's negative, positive, negative. That is also down below. Okay, so I have three different colors, but we do not want to be in this area. This is bad. We're not making any kind of money whatsoever. So if you think about it, the only time you're going to make profit is if you sell your shirts between 50 to 120 of them. If you sell more than 120, you're going to be in debt. If you sell less than 50, you're also going to be in debt. Again, this area is where you're making the big bank. So keep that in mind. That's what they're going to go ahead and describe here for you. Their graph is a lot more accurate compared to mine. Here, this one doesn't, keep in mind, this doesn't touch the x-axis. So there's no zero there. There's only two zeros, that 50 and the 120. And this is the only time you're making profit. So if you sell your shirts anywhere from 50 to 120, preferably if you sell them like around 100, that's when you're going to make the most amount of money. But again, it's like you'd rather be in profit of zero than be in debt. So that's how we're going to go ahead and interpret it. As you can see here, this is in the negative area. This is in the positive. Again, that's where you want to make sure that that's the money. That's where you want to make your money at. And so selling your shirts between 50 to 120 is the only guarantee that you're going to make profit. And let's go ahead and take a look at this one on side 27 here. So it says a population instantaneous growth rate is at a rate at which it grows for every instant in time. Function R gives the instantaneous growth rate of the bacterial population X hours after the start of the experiment. Use the graphing tool to graph the function and then complete the statements. The instantaneous growth rate is 0 at blank hours. So again, if you're trying to find the zeros, go ahead and find those factors. So if we take a look, I had that 0.05, but this x minus 1 tells me x equals 1. Remember, opposite sign. X equals -3, that's at 3. And x equals -5, that's 5. So at 1, 3, and 5 hours after the start of the experiment. So that's when the rate is 0. The population increases between blank and after hours of the experiment, the population decreases between blank hours. So again, you can go ahead and graph this. You can go ahead and use the graphing tool. My suggestion is the Desmos graphing tool. So again, desmos.com, or again, if you type it into Google, Desmos graphing calculator, and just type in the function that you see. Instead of r of x, you want to replace that with y, and you should get the graph. Now, I'm gonna just do the sign table. So here is my graph. This is B for my bacteria cells. This is -B, so meaning that there's no bacteria cells. And this is my X for the hours. Oops, ow. Let me just spell it out. Okay. So I have it at 1, at 2, 3, 4, 5. Okay. So the points that I'm going to test are the ones not on here. So I'm going to test out, you know what? I don't mind testing out 0. So I'm going to go ahead and do the sign chart. So I'm going to do test out 0. I'm going to test out 2. I'm going to test out 2, 3, 4. And then I'm going to test out 6. So that is 0's right here. This is right here for 2. This is 4. And this is 6. So now if I do a sign table, we have this positive sign already here. This is x minus 1, x minus 3, and x minus 5, and then we're going to get the sign charts here. So if let's go ahead and do this here. So this first value, the 0.05 is always positive. So I'm going to just write that there. And then I'm just going to go down by column at this point here. Oops. All right. So if we plug in 0 first, 0 minus 1 is negative 1. 0 minus 3 is also negative. 0 times, or 0 minus 5 is negative as well. Positive and negative is a negative, times a negative is positive, times a negative gives us negative. So this is coming from the negative side. Now between 0 and 2, or between 1 and 3, so that 2 minus 1 is positive, 2 minus 3 is negative, 2 minus 5 is also negative. Positive, that's a positive, still positive. 4 minus 1 is positive, 4 minus 3 is also a positive 1. 4 minus 5 is a negative. So they're all positives except for this negative. That changes the sign there. 6 minus 1 is positive 5. 6 minus 3 is also positive. 6 minus 1 is positive. So now that I can roughly estimate, it doesn't have to be exact, or if you want it to be exact, you can use a graphing calculator. This is coming from the negative side, and from 1 to 3, it's going to be positive. And then it's going to be negative, oops, and then positive again, okay? So now the population increases. When is my population increasing? From between what and what? So if you think about it compared to the zeros, it's gonna be that 1 and 3. That's the only time it is increasing. So I'm talking about this piece right here. And again, if you look through the patterns, 0 and 1, we know that's in the negative, 1 to 3, and then 3 to 5, we know it's decreasing down below. And then you would test out the same theory, but when is it decreasing? So is it decreasing from 0 to 1? From 0 to 1 right here, it's going up. But from 1 to 3, it's increasing, and then 3 to 5 down here, it loops down. There's your decrease. So again, go ahead and submit that and enter your answers there based off of our graph. And we already made it to our summary, so the ending of this. So again, remember how we like to break down our polynomials to factors and then use those factors to determine our zeros, which in other words are our solutions. Another thing that is a key important is the multiplicity. If it is to an even power, it is going to touch the 0 and bounce in the same direction that it was coming from. If it is an odd power, it's just going to go through and curve off. What's another thing? We got multiplicity. Zeros and solutions are the same thing. Don't forget about the shortcut, but again, if you forget, you can take the factor, set it equal to 0, and you would solve for x, and you'll find your 0 there. And that concludes this tutorial for factors, zeros, and solutions polynomial equations.